Hello, good afternoon, everyone. How are you feeling today? I guess tired on this long day, so I'll try to keep it light. Well, my name is Yariv Lukach. I'm a Director of Data Services at LivePerson for the past 3 years. And I have more than 10 years of experience as a developer and manager. And the thing that I like most in this industry is that is overcoming a major challenge that seems impossible at first. For example, when you're skydiving and the door of the plane is open, you look around and you look downstairs and you think that it is impossible, but once you jump, it's the most thrilling and satisfaction feeling. So I'm not going to talk about skydiving today. I'm going to talk about real-time sentiment analysis, and what are you going to benefit from it? I think that you will learn 3 things. You will learn how to design the right architecture to do it, and you will learn what are the right tools that you can use in order to do the sentiment analysis, and you will learn about the obstacles that you will need to tackle down the road. So just for those of you who doesn't know LivePerson yet, we are the pioneers of the live chat. Our CEO already developed it in the early 19s. And we since then keep growing. We have more than 1,000 employees, more than 8,000 customers around the world. And as a SaaS company, we gather all the data from all our customers into one place, into our farms. So we have a lot of data that we need to process and analyze. So this is our company. Now, what is the business case? It's simple. It looks simple. Tell us what is the sentiment of our customers while chatting with us. So when you think about it, you can divide it into 2 challenges. The first is the infrastructure challenge. How to support this large-scale sentiment processing, and how to do it flexible enough to replace the engine if I want. And the second one is the NLP challenge. Which tool should I use? And what is this sentiment engine? So let's start with the infrastructure. I will tell you how we at LivePerson design our architecture, and by this you will understand how and where you should put the sentiment engine. So first we have the chat and monitoring systems. These systems are real-time systems. They have a strict SLA. They need to be highly available. So for those kind of systems, you don't want them to compute or process data that they doesn't have to. So you decouple these producers from the other systems, from the processing system, and you just throw events of data downstream. And we use Kafka for doing it, and Arvro in order to have a unified data model, and in order to be able to decouple between the producers and the consumers. So this is our middleware. And from the middleware, we have 2 streams. We have the offline stream, which we use the Hadoop and the Vertica above it and MicroStrategy for the visualization. Of course, the Hadoop is our data single point of truth. And from Hadoop, we can process the data for analyzing. We have the second flow, which is the real-time flow. In this flow, we use Storm as the complex event processing. We have all those events that we throw from the producers. And in Storm, we can process it, we can do the computation, we can do real-time aggregation for dashboards, and put it inside Couchbase or Cassandra, depends on the problem. And in the end, we have the back office and the visualization systems that the agents or our customers can use to visualize and to see their data. When I say real time, I'm talking about something like 300 milliseconds or less than a second. So any operation that can be computed in this time frame can be real time. So now when we place this architecture, it is obvious that the sentiment engine should be sitting here. So if we put the sentiment engine and the processing in Storm and insert the data to Cassandra or Couchbase, we can do it within less than a second, and it is a good solution for a chat that if you think it's a human chat, so you have less than a second, it's enough for us to give the feedback of the sentiment. So now that we conclude the challenge of the infrastructure, let's talk about the NLP challenge. Let's take this sentence as an example. You can see here, this is a real sentence that one of our customers received. This chat is an amazing example of why I don't want to stay with you. So for us humans, it's obvious that this is a negative sentiment. But for the computer, it's a little tricky because there is a positive phrasing inside, amazing example, and there is also a negative. So how will the computer choose whether this sentence is negative or positive? This is the challenge of the sentiment tools. So what is the sentiment engine? How can I choose the right solution? As you can see, there are plenty of solutions out there. There are also plenty of measurements, and you can also you can check them by various of variables. You can see here all the list, and there are a lot more. So we started to think about how can we narrow down these categories in order to select the right solution. And we came up with the question, what types of solutions are there? And we defined type as the sentiment classification technique. So what are the techniques that we have? We have lexicon-based. Lexicon-based technique is dictionary-based or corpus-based. There are a lot of tools that are using it. It's called bag of words. There are several sentiment terms or opinion words, a list of opinion words inside the tool that helps the engine to understand whether the sentence is positive or negative. It has also, might has also some statistical computations, but this is the base of the lexical solution. There is also the supervised machine learning. In machine learning, you don't have to put any sentiment terms or something like this. You just need to feed it with a training set, with tagged training set. And once you do it, you will have your output. Of course, there are plenty of algorithms that can be implemented in this. You also have the unsupervised machine learning. And in this type, you just don't need to train it with a tagged corpus. You just need it to run and learn by itself. So what are the criteria that we have for comparison? So we chose the accuracy potential. Most of the tools can get easily to 70 or 80% accuracy, but what is the potential of the tool to get above this? We have also the cost of solution, of training, of maintenance, and we have the time to market that if we want to get with the feature fast or not, and we have the tell me what I don't know potential. There are tools that can give you something that you didn't expect it to get. Good things, of course. So once we put this in a table, we can see that in the lexical-based solution, most of the time you will spend on maintenance because there are a lot of accounts, a lot of sentiment terms for various of verticals, and you will always need to maintain this list that you have. And you will need also some expertise in NLP to understand the right terms or opinions. So this is what lexical-based have. The machine learning, in the machine learning, you will waste most of your time in training because you need to have a large train set, that tagged train set, in order to feed this machine learning. And in the unsupervised machine learning, you will probably have to invest a lot in the solution itself. It is not a trivial task to do. You can see here that as you go down, you will need less NLP expertise and more machine learning expertise or engineering expertise. We at LivePerson decided to choose the machine learning supervised by the solution of Stanford sentiment. A couple of words about Stanford. It was the right solution for us because it uses the same language that we use. It's the Java, and it is a jar that you can integrate easily into the system. It has a good processing performance for short sentences, but in chat we have short sentences, so on. So for us, the Stanford was a really good choice. But now that we choose the tool, how can we measure it? Is accuracy a good measurement? Not exactly. Why? Let's take, for example, this data. Let's say that you have a skew data like this, that you have 90% of your data is in neutral and 10% is positive or negative. So obviously, you can take a trivial model that scores all the data as neutral, and you will get 90% accuracy. So it's not good enough. So how can we measure the model? First, you should ask two questions. What is the importance of each sentiment class according to your business? There is negative, neutral, positive. In most cases, neutral is less important. The second question is, what is more important to your business, high recall or high precision? And you can see here this sentence. Help me understand why you can't just disconnect us. It's obviously negative. But what will happen if your tool will show it as a positive? What impact will it do to your business? Or whether you prefer not to show it at all? So this is the type of the question that you need to ask yourself in order to choose if you want high recall or high precision. Let's take, for example, the chat sentiment. In the chat sentiment world, we prefer to reduce our false alarm. We don't want the agent to see sentences or chats that are not really important to him. So we want high precision. We prefer to let him to show him the chats that we think that are negative and positive, but we don't want to miss. But in fraud detection, for example, they prefer to catch all the positive and negative in order not to miss any fraud. Let's say 20 million fraud, you don't want to miss. So this is the high recall. So in the chat business, the answers are we care about negative and positive, and we want high precision on negative and positive. The conclusion that this is how we will measure our model. Now, let's see how Stanford, the initial model, looked like for our chat sentences. And you see that it doesn't do well. All those sentences, you can see that they are negative sentences. But the initial model of Stanford gave us a neutral on the first one and positive on the other ones. And the answer for this is the train set. Stanford initial model was trained on movie reviews. So why the precision is so low? Because they say that the precision was above 80%. So let's look at the distribution of the sentiment classes. You see that in movie reviews, we have most of the sentences are either positive or negative. But in chat, most of our sentences are neutral. And this is part of the reason for the difference between the accuracy. And this is the reason that we had to do training. So how can we train and optimize your model? You have a useless training set. You can choose, let's say that this is our data, and you can choose randomly a data set, and you can find data that the model detects as a neutral. So it doesn't help you. You will train the model with data that it is already know. So you need to choose data that the model detected as negative but was wrong. So we need to first run the model, tag the data, and see where it was wrong, and then you can take this data and train the model with it. So we've done this. We've done tagging parties in our office. We developed a tagging tool. Part of the problem was that our data is internal only, and we cannot expose it. So we have done an internal crowdsource, and we got to improve the model by 300%, and this was the result. We got what we wanted. Now, let's see the big picture. I talked about only about the sentence, but in chat we have several sentences. So what is the sentiment of the chat in each point? So for doing it, you also need to have a sort of a heuristic above your sentiment score. You can score each sentence, but now you need to understand what is the right sentiment till now of the conversation. So we can do it by several options. You can do aggregation, you can do an average, you can do a weighted average, but weighted by what? By time, by length of the sentence. We chose to do it by EMA, by exponential moving average of the number of sentences. So we gave weight, much more weight to the last sentence till the present time in order to do the switch between the positive or negative sentences. So what did we talk about till now? For conclusion, we know how to design a real-time sentiment analysis system, and how to choose the right sentiment tool, and how to measure and train your sentiment solution. Thank you, everybody. Thank you, Tomati.